Hello and welcome to another lecture on continuity and differentiability. Today we shall be discussing certain rules that are more frequently used while finding the derivative of a given function or expression. The first rule that we are going to discuss is the product rule. Later we are going to discuss about quotient rule. After that we are going to find the chain rule for the given function, and finally we shall conclude by discussing some numerical problems that would be based on the aforesaid rules. Now beginning with the product rule for differentiation, we consider the functions fx and gx, which are differentiable functions at x, and if fx into gs is also differentiable such that the derivative of fx into gx with respect to x is equal to fx into derivative of gx with respect to x plus gx into derivative of fx with respect to x. Thus the derivative of the product of two differentiable functions is equal to first function into derivative of second function plus second function into derivative of first function. This is known as the product rule. Next we are going to discuss the extension of product rule for differentiation. Here we have three functions fx, gx and hx, which are differentiable at x. Then the derivative of the product of f, g and h with respect to x is equal to fx into hx into derivative of gx with respect to x plus hx into gx into derivative of f with respect to x plus fx into gx into derivative of hx with respect to x. Thus we can find the derivative of two or three functions that are derivable by the use of product rule for differentiation. Next we come to the quotient rule for differentiation. Here if two functions fx and gx are differentiable at x and we have a function which is equal to fx divided by gx such that gx is not equal to 0, then the derivative of fx by gx with respect to x is equal to gx into differentiation of fx with respect to x minus fx into differentiation of gx with respect to x whole divided by square of gx square, provided that gx is not equal to 0. Thus the derivative of the quotient of two differentiable equations is equal to denominator into derivative of numerator minus numerator into derivative of denominator whole divided by the square of denominator. This is known as the quotient rule for differentiation. Next we have the chain rule, in which we have the extension of a function of a function. For that let us consider if y is equal to function of u is a function of v and v is a function of x, then dy by dx is equal to dy by du into du by dv into dv by dx. That is, derivative of y with respect to x is equal to derivative of y with respect to u into derivative of u with respect to v into derivative of v with respect to x. This is called the chain rule and is very useful and powerful tool in differentiation. Now using the afore discussed rules, we can evaluate the value of the given differentiation equation easily. Next we are going to discuss some numerical problems that would be based on the use of the rules that we have discussed in this lecture. Now here we have a problem in which we have to differentiate the given function, which is 2x cube minus 7 into 9x5 plus 2x square minus 3. In order to solve this numerical problem, let us suppose y equal to bracket 2x cube minus 7 bracket closed bracket 9x5 plus 2x square minus 3 bracket closed. Now this value or this function y is to be differentiated with respect to x, and thus we have dy by dx equal to 2x cube minus 7 into differentiation of 9x5 plus 2x square minus 3 with respect to x plus 9x5 plus 2x square minus 3 into derivative of 2x cube minus 7 with respect to x. Now here we have used the product rule. Now this is equal to 2x cube minus 7 into differentiation of 9x5 plus 2x square minus 3 with respect to x, which is equal to 9 into 5 x to power 4 plus 2 into 2 x plus 9x5 plus 2x square minus 3 into differentiation of 2x cube minus 7, which is 2 into 3 x square. On simplification we have 2x cube minus 7 into 45 x4 plus 4x plus 9x5 plus 2x square minus 3 into 6x square, which can be further simplified as 90x7 plus 8x4 minus 315x4 minus 28x plus 54x7 plus 12x4 minus 18x square, which can be further rewritten or simplified as 144x7 minus 295x4 minus 18x square minus 28x. Thus, we have found the value of the given function after differentiation. Now we have another problem in which we are required to differentiate the following function, which is equal to 3x minus 2 whole divided by 5x square plus 7. Now let us consider y equal to 3x minus 2 divided by 5x square plus 7, which is to be differentiated with respect to x, and thus we have dy by dx equal to 5x square plus 7 into differentiation of 3x minus 2 with respect to x minus 3x minus 2 into differentiation of 5x square plus 7 with respect to x whole divided by 5x square plus 7 whole square. Now this value has been obtained by use of quotient rule that we have discussed in this lecture. On differentiation we have dy by dx equal to 5x square plus 7 into 3 into 1 minus 3x minus 2 into 5 into 2x whole divided by 5x square plus 7 with whole to power 2. This can be further simplified as 15x square plus 21 minus 10x into 3x minus 2 whole divided by 5x square plus 7 whole to power 2. This on simplification gives us minus 15x square minus 20x minus 21 whole divided by 5x square plus 7 whole to power 2. Thus, by differentiating the term 3x minus 2 whole divided by 5x square plus 7, we have the derivative of y, which is 3x minus 2 divided by 5x square plus 7 with respect to x as minus 15x square minus 20x minus 21 whole divided by 5x square plus 7 whole to power 2. With this we conclude this lecture on differentiation, which was based on the product rule, chain rule and quotient rule which for differentiation.